So coming back to the question we left. So here what we have passed, that we have passed 10.5 and 20.5. So what I said that this 20.5, this parameter is mapped to this parameter, okay, because this is of type double and by default compiler takes, okay, C++ treats 20.5 as double. If I have put a f here, then it will be of type float, okay. So then the scenario will be different, okay. So now what will happen, now the implicit conversions will take place, okay. So what compiler will do, okay, so this particular value, this floating point value will be implicitly converted, okay. So for this particular variable, the compiler will implicitly convert this 10.5 into 10, okay, because now what we are doing, we are narrowing. So this double value is being converted, standard conversion is take place by the compiler, and it will convert it into an integer value, okay. So here we can say an implicit conversion is done by compiler, okay, not by the user, by the compiler. And compiler is not, okay, it is ignoring this second, okay, function, okay, because there is no best match, okay, there is no match. If there has been a match, then the compiler would have processed this particular function, okay. But as 20.5 is not mapped with this float and 10.5 is not mapped with this integer, so compiler will not treat this function for the particular task, okay. If compiler found any one match, okay, variable variable that has been passed, okay, from the calling function to the, okay, to the call function, okay, if this particular thing has happened, then the compiler will, okay, the compiler will treat, okay, the second variable, okay, and it will just try to implicitly convert the variable, okay, depending upon the rules, okay. So if, so in this case, okay, in this case, if we try to run this code, so this condition is failed, okay, it will not run. So the compiler will treat this 10.5 as 10, it will be treated as 10, okay, and it will be treated as 20.5, and the result will be 30.5 will be, okay, obtained, okay. If, for example, if this has been, okay, if we have just put an f here, okay, now this is being treated as, this is a double and this is a floating point variable. So now compiler will go, okay, it will check the first value, okay, this first value is not mapped because this is of type double, this is of type int. The compiler will try to map the second value, okay, the second parameter. So this is now 20.5 and this is double. Now this is different, this is now floating point, okay, this is a floating point, now this is a float and this is double, so also this is not mapping, so the compiler will ignore this, okay. In the second case, now compiler will ignore this, compiler will now treat, will come to the second function and will try to search for the parameters, if the parameters are mapping or not. So in the first case, this parameter is not mapped, but the second parameter is mapped, okay. So a best match has been found for the compiler, okay, a best match, because this is floating point, and also the definition part we have, okay, we have declared this as a floating point variable, a float variable. So a best match is there, so the compiler will try to convert this parameter. Now this parameter will again be implicitly converted from 10.5 to an integer, okay. So again the output will be 10 and 20.5f, that is equal to 30.5. So if we try to change the cases, so in both the cases the output is 30.5. So in this way the compiler will search for the best match, okay. So you have to remember the rules. And the second is, okay, the second is the perfect match. So what is the perfect match? For example, if I say that, if, okay, perfect match means there are no implicit type conversions, okay. So if there is a function, okay, int add, and if I have just passed int a comma int b, okay, and inside this I have returned a plus b, okay, and in the second one, okay, if I have just passed, okay, for example, I have just written it as float add, and I have just written double a and int b. Okay, and I have returned as a plus b. So if in main, okay, if inside main I just call the function, if I just write cout, and if I just write, okay, let us suppose add, and I write 10 comma 20, okay, and here I write cout add 10.53 comma 20. Okay, so now in this case, okay, this add function, okay, this is the add function, this function is common to both. Okay, we, okay, all the particular you can say the properties of function overloading is being justified here. Okay, the return type is different, okay, the return type is different, order is different, okay, and the name of the function is same. All the properties have been defined here. So now the compiler, by when we compile this particular code, so during compilation time the compiler will map this function calling, okay, with the definition part. So, okay, so it will map like this, that what parameters we have passed during calling time, it will be mapped with the parameters that are present in the definition. So here you can say 10 and 20. So here also the type of the variable is int a and this is also int b. So this is a perfect match. Okay, the compiler will found a perfect match. It won't go in any other function because we can't write any other function of type in which we just write int a and int b, because if we write this, so it will be, you can say the compiler will raise an error that you have redeclared the function. Okay, because we can't write any function like this again. Okay, most of you will think that if what happens that if I write like this, so if I write this, okay, so there will be an error because now there are two functions and both the functions, okay, are having the same prototype. This float and this integer is not responsible, okay, in function overloading. Okay, the three things that are responsible is the name of the function, the type of the parameters, and the order of the parameters that we have passed. Okay, so here the type is same, okay, the order is same, and the number of parameters are same, so there will be an error. So we don't do this, okay, so it won't be there. So we have to think we have to think logical. Okay, we need not have to think that if we put this thing that what will happen. If you think logical, then logical output will be there. If you think illogical, then the program will be, okay, then you will be in a problem, because then you will be confused that why it is happening and what is the real cause. So don't try to put the vague things in your program, or that will, okay, that will try to, okay, hamper your situation. Okay, so now this 10.53 will be mapped with this double perfectly, and this 20 will be mapped with this integer perfectly, and the output will be 30 and, okay, 30.53. So there is also a third case. Okay, in third case what happens, so if we have a function, okay, taking the example of the same function, so for example the return type is float add. Okay, so the function is add, and if the prototype is, let us suppose, float a and int b. Okay, so this is the definition, and I'm just returning a plus b, and considering the second function is double add int a and float b, and it will just return a plus b. So here you can see that the ordering is also done here. Okay, the order matters. In the first scenario the order is float is first and integer is second, but in the second case int is first and float is second, and the same function name is being used in both the cases. So ordering, the number of parameters, and the return type of the parameters, all the three are maintained here. So let us, okay, divide this. So if I just write main, and if I just write, so cout and just pass add and 10.5 comma 20.5, for example. Okay, for example these two parameters we have passed. Now what will happen, the compiler will now compiler will be in a state of dilemma. Okay, compiler will be in a state of confusion. Okay, so this 10.5 is not mapping with this float because it is of type double and it is of type float. Similarly, this 20.5 is also not mapping with this second parameter that is of type int. In a similar way, this 10.5 is also not mapping with the first parameter of the second function, that is integer, and in a similar way this 20.5 is also not mapping with the second parameter of the second function, that is float. So now we have two functions and the function call is unable to map with any of these two functions. It means that the compiler is now not in a condition to map these, okay, these two function definitions with the function call. Okay, if the compiler tries to invoke the implicit conversions, so for the first function the compiler can do, okay, for 10.5 it can be, from 10.5 it can be reduced to 10.5 f for this float, that is a narrowing, and this 20.5 that is a double, it can be reduced to 20 for this int. So this, in the second case also, this 10.5 can be, okay, converted to 10 by the compiler, that is an implicit narrowing, and this 20.5 that is double can also be converted to 20.5 f. But if this happens, then the compiler will be confused that for which function I have to consider, okay, which function I have to consider, because there is no best case, there is no best case in both the functions. Okay, so best case, okay, best case is missing, best case is missing in both the functions. If any one of the parameter, okay, if any one of the parameter would have been matched by the compiler, then the compiler would have been processed with that particular function only and the implicit conversions would have been take place. But now both the functions are in a such condition that the function call is unable to map with any of these functions, because there is not a single parameter that can be mapped with the parameters of this function call. So there is a state of ambiguity for the compiler. Compiler can't just as to which function I have to map and I have to produce the correct output. So the output will be an ambiguous condition. Okay, an ambiguous condition will be there. Okay, and it will result in an error. So a compile time, if we try to compile this program, so when we compile this, okay, when we compile this, so compiler will result in an error. Okay, and compile time error will be there, that is ambiguity. Okay, that is ambiguity in both the functions. Ambiguity in both the functions means compiler is now confused that should I support the first function or should I support the second function. Okay, there is a state of dilemma, there is a state of confusion for the compiler in supporting any of these two functions, because there is not a single best case that is being present here. Okay, best case is missing. Okay, so in this way, okay, for function overloading we have to see, if we pass these type of parameters, so we have to see three cases, that is the best match, that is the exact match, and the third is the ambiguity. So the compiler, okay, the compiler will follow the function overloading by the three matches. Okay, so it will opt for the exact match in which all the parameters are correctly matched. Okay, the best case, if any one of the parameter is matching, then the compiler will proceed and do the implicit conversion for the other parameters, and if there is no best match and if there is no exact match, then there is a condition of ambiguity for the compiler and the compile time error will be there. Okay, so we will do this question with the help of a practical demonstration in the subsequent lectures. So I hope this is clear to you now. So you just, okay, revise the concept, okay, just see both the lectures and try to grasp the concepts. Okay, thanks.